add my new people too. Where's my dojo?
Oh God. I thought we were starting notes. Yeah, notes for.
How do I go to my class? Oh, come on in. Thank you for welcoming me. This has changed. I'm gonna have to add somebody. Reina Soto. Where is the green light on the traffic signal? On the bottom? Are you sure about that?
Well, there's some arrows.
Raise your hand if you say it's on the bottom.
Wait, is there arrows on it? That's really
Raise your hand if you say it's on the top. It's on the bottom.
Ooh, the arrows are on the bottom. How do you guys really?
Hey, you know what?
Oh
It's
my God.
like you don't consider those things every day, right? Here, I have a challenge for you. I have a challenge for you.
What?
Just because I want to have a little fun right now.
Okay, what?
I have a challenge for you. On that paper you have, draw the front of a penny. Because you guys have seen pennies lots of times, right?
Oh God, I don't remember.
Draw the front of a penny with as much detail as you can remember.
I keep drawing
The face side. Draw the face side.
Yeah, I don't. I just.
Draw it with as much detail. It doesn't have to be perfect, but just as much detail as you remember. See, let's see how much you rember. And then I'll bring up a picture of a penny.
Words around it right here.
I don't think good old Abe would like that.
Abe Lincoln's gonna look looking weird. I don't know how to do this. Is this top hat in it? No.
Does that have an emoji face? That's what I would call it. Like,
No, it's not.
emoji face. It's like-
I like it. Oh my God, what did I do?
No cheating over there.
I like it. Like he's pregnant.
I like it. Stop it. I want it. I want it.
Oh, I didn't do my circle right.
Oh, that's what
This top hat isn't in this?
No.
What's the point of this?
There's just how observant are you? How much do you pay detail to attention to detail? How many people got Abe Lincoln, of course, right? How many people drew the top hat? You drew the top hat? Because that's what he's known for, right? How many people got the In God We Trust?
I got it on the wrong side.
How many people got Liberty?
I couldn't fit in.
You put squiggles here?
Yeah.
Good, but so you remember there's something there, right? Good, that's a big plus. How many people put the 2013 or the date?
What year?
The year, a year? How many people put a letter under there?
Isn't that like what? Shit.
Mine says 2000.
What?
That one doesn't have a letter.
Oh, that's new, huh?
This one is 2005 D.
So this one's older. This one doesn't have it.
This one says 2005 and it has D. So
I wonder what that's about.
let's Google
What
it.
letters are on there?
I don't know what that's about, but not all of them have it.
Look it up.
Yeah, look it up. Ask why there's
How many people drew that penny?
credit union.
That's the one
There's a half.
See, that one doesn't. 1925 doesn't have one. 1990 has it. 43 does not. What is that? From the Planet of the Apes?
No, that's not on my list.
That was good. Well, I don't know what that's about, but if you care enough to want to know, you guys can look it up later. What is our assistant principal's name? Let's dojo. Peyton, do you know? Watch out. Yes, it is.
I'll always have it.
What's our principal's name?
Trigolate.
See, I'll tell you what's I don't know.
How many people know his nickname? Mr. Triggerlades.
Greg.
Trigo Bay.
Oh,
Ew.
Oh, that's on the.
I really hope you
I know. I just saw it. It's not really his nickname, but I thought it was hilarious.
He has a nice Jeep.
I just remember when the superintendent came in.
Well, you know what? When you make thousands of dollars, you can afford a nice Jeep. When you're a teacher, you
Wait,
can.
what else? I know he was a coach, but like, what else did he do?
All right. So, anyways, let's go.
What did he do?
What do you do? What?
Like, what other jobs did he have other than?
No, I think he's always been a teacher, but he coached as well. He did both.
They
I know
made
he's
thousands
been a
of dollars
principal.
off of
No, he's a principal. Principals make good money, I think.
them. How much?
I don't know.
He's like,
If I really wanted to know, I could request like, you know, how much money do teachers make. You can do that, you know that, right?
You can request.
Yeah, it's called something public information.
Really?
Yeah, if you care enough to know. All right, cool. Let's continue.
90 grand a year? That's cool.
Here we go. So, actually, were there any questions on the homework? Should I answer anything from there? You guys are good?
I have
My
one.
Questions?
hand is cramping.
No? Sure?
Oh,
All right.
I
What?
think my hand is broken.
You have one?
yeah.
Oh, I almost.
So loud.
Let's go.
I cannot wait to go to the shower. I look like this. Did you say you need to get taller?
There we go.
I had a farmer's stand on my
Which one did you want to know about? So,
I can't remember if it was 8 or 9.
well, we'll take a look at 8, and if that's not it, then we'll go to 9. Okay?
Okay.
Are you looking it up now?
Yeah.
Okay. This is 8 right here. It's blank.
It was pretty hard. I didn't know which one.
That the one? I don't think so.
No, that must be 9.
That one? I kid. I don't have questions.
12.
12? Ho ho ho.
Oh,
It was that one, huh?
yeah.
I
I'm
thought
so
so.
happy about this. He just.
This is good math. It's great. Let me get my little snapshot tool. Snapshot from Progressive.
I got it. The answers, but
What does that even do?
I need to
Snapshot from Progressive. I think you have to plug it into your car, and it randomly monitors whether you're like speeding, buckled in or not, and if you're following all the rules.
How do they know if you're speeding though?
It depends on how fast you're going.
Like,
I don't know. It just collects all this data, and then they can figure it out. All right. Let's start by factoring the denominators, okay? So, first step is to factor those denominators so you can see what all the factors are, and you can try to get the LCD, the least common denominator. These are both squares, so it looks like we're going to have a something with x here, right? And then two y's. So two numbers that are going to multiply to this, but have a difference of 5. Looks like it's going to be a y and a 6y. And this one's going to be positive, and this one's going to be negative. Whoa, that's horrible. You know what I meant, right? All right, on the other side, same thing. Same thing. Looks like we're going to have an x and a y, and x and a 2y. This will be positive. That will be negative. Okay? So there's the factoring part. Now, deciding on your denominator, I'm going to use the black this time. I need an x minus y. They both have the same amount, so I'm only going to write it once. Because remember, that's just a number. We're going to need the x plus 6y. And we're going to need the x plus 2y. So there's my denominator. Okay? Time to adjust the numerator. Numerator started with 6x minus 5y. I'm going to do this bit. What does this denominator, the new denominator, have that it did not have before? The x plus 2y. So I need to multiply it by x plus 2y. And then I can subtract what was there, like blue, what was there, which is 5x plus 3y. Now, what does the new denominator have that the old denominator did not have? The x plus 6y. So x plus 6y. So there's our fraction pretty much. All we need to do is simplify. Okay. All right, I'm going to move this up a little bit. Okay. Let's expand the red part. 6x squared. What is that? 12 minus 5. 7xy. And then negative 10y. Squared. Good looking out. Right? Minus, and I'm going to do a parenthesis because I'm going to have to distribute this negative. Minus, what is that? 5x squared, 30 plus 3. And then finally, what is that? 18y squared. Right? Okay. Okay. I'm going to use green. 6x squared minus 5x squared is just x squared, correct? 7xy, take away 33xy, positive, what, 26 xy, and then negative 10y squared minus 18 would be negative 28y squared. So there's the numerator simplified. What's my question now? Will it?
Fraction.
I need buzzards.
No.
Will it factor? I don't know. Can anybody see it off the top of their head? I can't. Holy smokes. I'm gonna use my calculator. I ain't trying to do that. Right? So it's really the square root of all that. So I'm gonna punch that in my calculator real quick. Second square root of 26 squared minus 4 times negative 28. Nope. According to me, it doesn't. But I'm feeling that there's a mistake in there because it didn't. So anyways, there's my numerator. And this is my denominator. Did anybody catch a mistake?
Should 26 be negative?
Should the 26 be negative?
Because it's 7y minus.
Well, even if it was negative and I plugged it in here, it wouldn't make a difference, would it? Because then I'm going to take that square it, which would still make that positive. But let's see, what did I do wrong?
That was.
Yeah, this should be a negative though, because we were taking away the 33, huh? But it's still not factorable. But thank you, you caught that. I feel like maybe I did this part wrong. That doesn't feel wrong. What do you guys think? 5x. 5 times 1 is 5x squared. 5 times 6 is 30, right? Even on a bad day. 33. I don't know. Well, let's plug it in. I guess we'll find out. Where'd that? Quotient. Alright, numerator is
X squared.
x to the second
minus,
26
yep, xy
xy
minus 28 y squared.
y squared. I got a feeling. Or our factors.
X minus 1.
X minus y.
Yeah, x plus 6y.
X plus 6y.
And then x plus 2y.
X plus 2y. Oh, cross your fingers. Yes. What are we looking at? I thought it was more mistaken. Because I was hoping something was that this numerator was gonna factor, you would cancel something, but. Alright, cool. Yay. What else you guys got? Was that all the questions? Let's get started. Let's get started with the F word. Fractions. Alright, let's do this then. No, say you're not tired. Say you're happy and you're excited.
No, I'm tired.
Clap your hands. Because you're happy and you know it. Okay. 7.3, complex fractions.
What's the name?
There's not much to say about it. These are just fractions with inside of fractions, inside of fractions, and they're. I guess that's what makes them a little complex, but they're not that bad. So that's what we'll be doing, okay? We're just going to be looking at complex fractions. So they look like this. Okay?
They're ugly.
They're beautiful. So let's get started, okay? Let's start by simplifying fractions. So let's start here. And if you just want to watch what I'm going to do, that's cool too. For now, I have one denominator here, don't I? So it's really just is one fraction and one fraction. So all I'm going to do is think about it as I've got a fraction being divided by a fraction. I can't really do that, so I'm going to multiply by the reciprocal, correct? So that would be 3y over y minus 2. You see that? And I'm going to see if, same as always, can I simplify anything? In this case, y can make one with that y, doesn't it? See it? Can I simplify it this way? No, because one's the sum and one's the difference, right? So that's going to become 3y plus 6 in the numerator and y minus 2 in the denominator for now.
How'd you get the plus 6?
Sorry, I jumped the spot. A step. This is 3 times the number y plus 2 over y minus 2, and then distribution. 3y plus 6 over y minus 2. Okay. Thank you. Questions there? No, just let me write it down. Stanford. Is that where you want to go? Just warm sweater. Oh yeah? Here. Next one, you guys ready? Yeah, there was nothing else we could do. What did they want to do? Oh, they left it like this. But I multiplied it out.
Are we gonna get it wrong if we do
No, that's more better.
that?
Okay, let's do this. You guys ready? Here's a way of looking at this. This obviously has a denominator of 1, doesn't it? Okay, so don't even look at this for now. I need a denominator with an x. I have a 4 that didn't have an x there, so I need to add it to it, and that's going to become negative 3 because that denominator did not change. Does everyone see what I did there?
Wait, say that again.
Okay. This might be a little better. Let me. Nobody understood what I did there, did I? Did you? This has a denominator of 1. Okay. Correct. So if I look at this fraction, what is the LCD? X, right? Or 1x? Do we need to write the 1? No. So what do I need to do to the 1 to get it to become that? So I did it to the top. 4x. Did that change? So will that change? There it is. Oh, that's horrible. My numbers get uglier and uglier. A little bit better, yeah? Cool? Alright. Now let's look at the denominator. Same thing. What do we need to have a denominator for these two fractions? X, right? Because there's a 1 there. What did I multiply the 1 by? X. So I do it to the top. That becomes a 5x minus 1. So there's my fraction. So it's just one fraction over one fraction. Not a mixed fraction, right? All crazy. Can anyone see step ahead already? What's going to happen? The x's are gone, aren't they? The x's are gone. So this and this are going to cancel each other out, and you're just left with 4x minus 3 over 5x minus 1. Okay? And if you want to go ahead and do the flipping thing to see it that way, you can. You're more than welcome to. You can get the same thing here. And I'll go ahead and show you. And I'll show you in the blue. Taking the numerator, 4x minus 3 over x, multiplying by the reciprocal of this will give you x over 5x minus 1. X and x makes 1, so you end up with that right there. Okay? Can you close your notebook real quick? Questions here? I just want to see the picture of the shirt, guys. Because it's funny. That's why I told you to close it. I wanted to see the other person on the picture. It's funny. All right, we're cool. Pop, pop, pop. Oh, that's crazy. Look at all that. Nah. You want to do all that? All right, cool. Simplifying fractions. Method 2. Oh, that's pretty cool. Do you guys see this one? What they did was try to get rid of the denominator of x by multiplying everything by x on numerator and denominator. So here this would cancel out, but here you would get 4x minus 3, hence the 4x minus 3. here these would cancel out, right? You would get 5x minus 1. That's a cool way of doing that. I'll just leave that up there if you guys want to copy that. I'm trying to leave you back for you, sorry.
Can I use the restroom?
Huh?
Can I use the restroom? May I use the restroom?
You may.
Do you know who they are, Mr. Williams? Do you know who they are?
Are they Muppets?
What place even does that?
Who are they?
Oh, he knows. I don't know.
Joaquinos?
I don't know.
Who's Joaquin?
Maybe that's how they call them in Spanish. But.
They call you Joaquin?
Wait, what are you talking about? What are you talking about?
I said Joaquinos.
I said he knows. That's what I said.
Oh, I heard you say Joaquinos.
I didn't say he.
Or did you say Joaquinos?
Maybe, I don't know.
I think that's what you said.
I
I
don't
heard
remember what I
Joaquin.
said.
Who are they? Are they from the Futurama?
No, it's from their YouTube video.
I don't know what YouTube videos are.
Right?
You only focus on his.
There's more videos on YouTube besides mine. Alright, cool. Here we go. Next one. You guys want to try that new method? They look pretty cool. See, no? You want to try the new one? The method 2?
Yes.
Let's try method 2. We're going to multiply both of these sides by y plus 1. Because that's the denominator here. So here's what's going to happen. When I distribute this, the new numerator, I'm going to put a little arrow here, it's going to become 3y times y plus 1. And in the other part, it'll be just plus 4 because this and this would make 1. So there's my numerator. Right? That's a one. It's a horrible 1. It's supposed to read plus 1. Plus 1. Sorry, Storm. That was pretty bad. That was like YH, huh? What am I multiplying this fraction by? Y. So I would get 2y squared minus 3. And all you gotta do is clean up the numerator. Yeah. Let's do that. Did someone say can you?
No.
Or did I hear it?
No.
She said, kidding me.
I said, are you kidding me? But it didn't do with that. And then he was like, yeah, I'll do it.
I'm just making stuff up all over the place. Right, Joaquin? Numerator, 3y squared plus 3y plus 4 over 2y squared minus 3. Will it factor? I don't think it will, but I'm going to try it anyway. It should be square root of 9 minus 4 times 12.
Sure.
Nope, that's going to be imaginary. That's way bigger than that, so you're done, 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 done. Are you playing a game?
No. Who plays games on computers?
You'd be surprised.
Okay, well, I don't. Yeah, I don't even turn on my computer. I did not touch my computer at all yesterday.
Wow.
At school.
Whoa,
Thank you.
why is it 3y squared? Hold on, did we get the same thing?
No.
Why did we not get the same thing?
You forgot the square on top.
So they did y and y plus 1.
I don't know.
What? Oh, they multiply both sides by both of them. How's that even legit?
It's cool, huh? Look at my dad in school and
Yeah, but if we're treating that as simply just subtraction. Oh, yeah. Oh, I don't like this method. That confused me. That confused me totally. No. Stick with method 1. Unless you like method 2, then we can mess with it later.
and then that's why they were like,
So, okay, so here they're saying, oh, that's just the same as we did before. Okay? Here, just 2 fractions. You got 5, y plus 2, y plus 2, y minus 2, over negative 3. Y plus 2's will cancel, and then you're going to get 5y minus 10. 5y minus 10 over negative 3. Yeah, it was here, but there's nothing that we can cancel, so it's not going to happen. Because it's a 5 and a y minus 2. That's the only reason I expanded it. Is it though?
Yeah, because the other one's less strict.
It's factored form.
I think it's my foundation.
Because see, if I get to here, that's where I would make my argument. See, if I get to here, and it says that simplified fully, see what I'm saying? I could still factor. So there's always debate. I think it'll take both, no matter what. But yeah, you gotta be careful with how they ask it. Is it factored form? Because then it would be that. And if it was, I don't know. I guess we'll pick that up as we go. Oh, they did method 2. Can I erase this ink so I can see what they're doing?
Go for it.
This is the first time I see method 2.
This is the first time you've ever seen it?
Method 2? Yeah. That's why I said, oh, that's cool. But I ruined it. I ruined it on my attempt. So here's what I did, obviously. And then I multiplied by the reciprocal. Oh, multiply by reciprocal, cancel those. So we got that. And then method 2 said, let's see here. All right, so then that means you're going to multiply numerator and denominator by this, right? Okay. Cancel. This would cancel. They would get 5y. Okay.
So what would happen to?
Go ahead.
So they would just multiply it like the top fraction.
Well, here's what they're doing. They're saying what would be, they're already thinking ahead, what's the least common denominator? Well, the LCD is this, isn't it? Because that is a factor of this. So like you said, you have to do the top, but you do the bottom. So they multiply both of those by that. Well, in this case, that makes 1. So you're going to get 5 times y minus 2. In this case, they're both there, so you get the minus 3.
Oh.
So yeah, I'm seeing that. I'm liking that. It kind of seals it more. Yeah, this one's a little more clear than the last one. Probably because the other one was there were fractions and whole numbers. All right, cool. So here, what is that, method 2? What do you guys want to do? Which one? Try method 1 first, and then we'll do method 2. All right, so method 1. This denominator is going to be AB. That's going to leave us with B minus A. In the numerator, this is going to be denominator of A squared, B squared. And we're going to end up with B squared minus A squared in the numerator. Multiply by the reciprocal. So you're going to get B minus A over AB times A squared B squared over B minus A, B plus A. B minus A is gone. that will take out these exponents. So you're left with AB over B plus A. Right? Try to making mistakes there. Did you catch any? Josh West? No? Did you catch any mistakes? Alright, so here's the tricky part, I guess. Method 2. It's going to be A squared B squared, right? So, I'm not seeing it. Let's see here. Let me just redo it here. Minus 1 over B squared. Okay, so if we're multiplying by A squared B squared, right? Then if I distribute this over here, I'm going to get, let's see here, that A would cancel one of those A's, right? So I would have A B squared minus A squared B over here, that would cancel that, so we would be ended up with B squared, and this would leave us with minus A squared. And if you go here to the numerator, they both have an A in common and a B in common.
The A squared will couldn't cancel?
Yeah, it did in the denominator. So here, common factors are an A and a B. That would leave me with B, not B squared. It would leave me with B minus A over that, which of course is factor if we went to conjugates. B plus A. There's that. Same thing. Okay. I'm not feeling this second method though. But you know what? It's a cool way of looking at it. It works, right? Don't mock it till you try it.
Don't mock it.
It works when you do.
Yeah, don't they say that? Don't mock it till
I
you
thought
try
it's
it.
don't knock it.
Don't knock it? Why would you knock on something?
But why would you mock it? Oh,
Because you're making fun of it, like, oh.
I thought it's knock. It is knock.
I don't know what it is.
Don't knock it till you try it.
Let's see.
He's gonna Google it.
I don't want to say it wrong anymore.
What is
Don't
yes.
till you
Yes.
try.
No, I'm gonna like ask her.
Don't knock it. Yeah. Wow, I'm already kicked the bucket and I'm barely saying it right. Well, yeah, I know, I'm pretty sure too there's like many songs I'm still not saying right. Got you guys about the Obamas though?
I asked her about it on Christmas. I was like, what?
Okay. There's a song that goes, I want to be
She what?
all by myself. You heard it, right?
What's that?
All by
Marie?
myself. So this one guy heard, I want to be Obama's L. So he's singing like, I want to be. I couldn't even do it. But I'm like, really? I'm like, okay. If you listen to it, like, I can. Okay. Now here's mine though. The Miley Cyrus wrecking ball. Like I came in like a wrecking ball. For the longest I was saying, I came in like a rainbow. I came in like a rainbow.
Mr. Munoz, can you like make that go away real quick? Okay. Make that go away. Wait, no. Yeah, just leave it right there.
Freeze.
Today's the last day to do it.
Where were you going without ever knowing the way? You ever heard that song?
What song are you singing? Okay,
It's
you
an
can change
older
it
song
now.
from the 90s. But it says, where were you going if you don't know the way? That's what the singer said in the lyrics. But when they were singing, I thought it was like, without knowing the wave. I was like, maybe it's like a secret, to know where to go. I don't know, whatever.
I'm so dead.
Man, I can butcher songs like no
You're
one.
good, Mr. Munoz. You can change it. How?
We're good? I'm just, you hear them, but you're not listening, you know what I mean? You ever catch yourself doing that? Like you're just like it's noise, but you don't know what you're saying, and then like you make stuff up.
Me during class.
I think everybody's done that.
It says beauty.
Okay. Oh, that's a different one. No, that's the same one. All right, simplify rational expressions with negative exponents. Ah! So now they threw negatives in at us.
Flip the table.
Yes. Here's what they really want us to do, which is to make complex fractions.
No.
But this,
That looks way harder.
it is. The reason you can't do what you said, just flip it, is because what you're doing, remember, this is a number, isn't it? So you're really taking the whole number up to the top, which is making that a to the negative 1. I guess that should work. Minus 5, b to the negative third to the negative 1. But then now that 5 has a negative 1 power. You see that? That's the dirty business right there. So what needs to happen, which isn't really bad. So if you just follow, we'll eke our way through. Is that a word? Or did I just make something up?
Eke our way through.
Yeah, like,
Yeah.
okay, I can say that.
He like.
So whatever has a negative exponent, we're just going to reciprocal that bad boy, which is the rule, right? So that a to the negative 2 is going to become 1 over a to the second plus 1 over b. Looking at the denominator now, that's going to be 1 over a minus 5. Now that 5 is okay. It doesn't have a negative exponent, so it doesn't need to flip anything. But the b does, the b to the third. So all that's going to happen is I'm going to bring that b to the third down to that, under that 5, just like that.
It's a straight line, man. I was talking about me, not you.
I was looking for my straight line.
Yeah, I was like,
Like, they're all perfect corner. Questions there on what I did here?
your eyes.
B.
Because it was negative here as a numerator, so all I did was put a fraction there and I brought that to the bottom of it.
No, the top one.
Because there's a 1 above it now. So this is really b to the negative 1. I put a fraction to it and I brought it down, which made it a positive 1. And what's left in the numerator? A 1. Thank you for asking. Thank you for asking.
I'm like so tired.
So if we did method 2, I'm thinking that we're multiplying by a squared b to the third. Right? But I'm not going to. I'm gonna use a method that I'm pretty good at and I already know. So looking at the numerator there, I need a squared b, which means this becomes b plus a squared. In the denominator, I'm going to need a denominator of a b to the third. Therefore, this is b to the third minus 5a. I'll pause. Let you process that.
So that's method, second method?
No.
No, that's just the first one.
I need to practice method 2 more. I mean, I'm thinking I know what I would do because I see it.
Oh, so we're finishing it.
Yeah. Go ahead, tell me. I can color code a little bit more. Okay. No, I can't. I don't have that many colors. But here's what's happening. If you look at this denominator, which is the a squared and b squared, I need both of those, don't I, in my denominator? What does the a squared not have? B. So there's my b right here.
Oh.
What did b not have?
A squared.
So there's the a squared.
Oh, okay, alright.
Okay, so the same idea with the denominator here. I need both a and b to the third. So I said, okay, what did a not have? The b cubed, right? So there's b cubed. And then what did the b to the third not have? A. So there's the 5 with the a. Cool? Alright, at this point, multiply by the reciprocal, yeah?
Yeah.
So multiply by a b to the third over b to the third minus 5a. And this is no longer there. So, this a will get rid of one of those a's. And this b will get rid of one of those. So that'll leave me with b to the second. I'm going to clean this up for now. Is that cool?
Wait.
So I've got b to the second times b plus a squared.
Hold up, what? Okay, you lost it? I said hold up, what?
Where did you?
Okay.
What's over here? I have a b squared left, right?
Okay,
So there's my b squared,
yeah.
and I'm multiplying it by b plus a.
Shoot, okay.
That's it.
Alright, I was
And then the denominator, I only have an a left here, and then I have that b to the third minus 5a.
Wait, what canceled out? Okay.
Oh, you canceled out the...
So you canceled out the top B with the bottom B, right?
One of them,
Okay, one of them.
because the other one had 3, right?
Yes.
That's why I have b squared left.
And then one of the A's.
And then this a over here, in the numerator, cancels out one of the a's in the denominator over here.
Alright. Okay. Alright. I think I'm good. I don't know.
I'm thinking that's it. Even if I expand it, b to the third plus a squared b squared, a b to the third. There's no way there's anything the same. I think that's it at that point.
Okay.
Siri, what's the weather like?
It's gonna rain.
Thanks, Siri. Oh, they did expand it. See? You just don't know sometimes.
Over it. No.
But that's what I got. See, this is what we got. Yeah, so we're done.
I don't know how I'm gonna get through today. And I only have 4 classes. You won't stop that.
Oh, sweet. We're done.
Woo!
Hip hip hooray!